How many access modifiers are there? 4. What are those? First one, public. Second one, private. Third one, protected. Fourth one, no name. Okay. Which is default in a class? No name. So no name is a default access modifier. Default access modifier in a class. Which is default in interface? Public. Public is a default access modifier in an interface. Package, no name. No name is a default access modifier in a package. Okay. Say there are 4 access modifiers. Without writing access modifier, also one type of access modifier in Java. But in C++, without writing access modifier, that will be considered as a private. If you don't write anything in C++, that is treated as private. Private, that is same. But in Java, private different, protected different, public different. If you don't write also one more type, that is no name. That type name not there. That is default. Okay. 4 access modifiers. Now, what is the scope of public? Public, no restriction. Anywhere you can access. Private, within the class. Protected, package and subclass. Subclass can be outside the package also. Default, no name, within the package. Okay. You studied in these 4, which is more restrictive access modifier? Private. After private, no name. Either write default also if you want. Now, next, protected. Next, public. Okay. This order also required for further. Write this order. More restrictive access modifier. Less restrictive access modifier. More restrictive access modifier, less restrictive access modifier. Public, there is no restriction. Private, default or no name. After that, protected. After that, public. More restrictive to less restrictive. The order. Is it over? More restrictive access modifier, less restrictive access modifier. Next point. Outer class cannot be private and cannot be protected in Java. Outer class cannot be private and cannot be protected in Java. Inner class concept further comes. For inner classes, we can write. But whatever you are learning, those are outer classes only. Present, you are learning outer classes. Class in a class is inner class. You are learning outer class only. Suppose class A, private class B, protected class C, public class A, D. If you write, suppose if you write like this, if you write like this, it is valid. It is error in Java. It is error in Java. It is valid. Only two access modifiers allowed for outer class. Private class, error in Java. Protected class, error in Java. Okay, write this point. So for classes, you cannot apply private, you cannot apply protected. Okay. Inner class you can apply. Outer class not possible. That's what. Outer class cannot be private and cannot be protected in Java. Outer class cannot be private and cannot be protected in Java. Oh, is it over? Same style. Outer interface cannot be private and cannot be protected in Java. Outer interface cannot be private and cannot be protected in Java. What is the interface? We'll see later. It is valid. It is error. It is error. It is valid. Outer interface cannot be private and cannot be protected in Java. What is interface? Further you'll understand. For private interface, protected interface, we cannot write. If you write, error comes. If you write, error comes. Okay. Is it over? In C++, private inheritance, protected inheritance, public inheritance types was there. That's what allowed. But Java doesn't support. That is the reason these are error. Here, before interface or before class, private, protected, if you write, error comes. You observe? Suppose B class, here, private, if I write, if I compile this one, see. compilation. See, modifier private not allowed here. Here not allowed. Okay. If you write protected, see, it is also error. Modifier protected not allowed here. Okay. You cannot write if you write error, but you can write public. It will compile. See, compiled. If you don't write any access modifier, also one access modifier, it will compile like this. Okay. Same style for interface. Suppose here int a, if it is there, here private also you can write, protected also you can write, public also you can write, default also you can use, no name. Suppose here one method, here also you can write private also, protected also, public also, default, no name also. All you can apply. But before class, not possible. Suppose further what we'll do, we'll write one more class here, like this. For this class, we can write. That's what I specified here. Outer. Outer class cannot be private and cannot be protected. Outer interface cannot be private and cannot be protected. Outer, I specified. So that means inner class supports. Inner classes, inner interfaces supports. That is further concept. Further we'll see. Okay. Here you can write all access modifier, but here we cannot write. Okay. These are points. These are all points. Remember, don't forget. Next. Relationships in Java. Relationships in Java. First one is a relationship. Second one has a relationship. Relationships in Java. First one is a relationship. Second one has a relationship. Note on is a relationship versus has a relationship. Is a relationship versus has a relationship. One side is a relationship. One more side has a relationship. Is a relationship versus has a relationship. Here is a relationship refers inheritance. Is a relationship refers inheritance. Has a relationship refers composition. Already you studied this one, creating a new class from an existing class is called as creating a new class from an existing class is called as inheritance. Here, creating an object of one class as a member of another class. Is called as composition. So is a relationship refers inheritance, has a relationship refers composition. Is a relationship nothing but inheritance. Whatever you studied, that is inheritance only. Is a relationship only. Why we are calling is a relationship, I'll explain. Whatever you studied, that is a relationship. Why we are calling inheritance as a is a relationship, I'll explain. Why we are calling inheritance like a is a relationship. I'll explain with examples. See, two types of relationships. Is a relationship, has a relationship. Is a relationship refers inheritance. Nothing but inheritance is a relationship, both are same. Has a relationship refers composition. Nothing but creating an object of one class as a member of another class is called as composition. If we create object of A class, if we create as a member of B class, in that case, you can call it as has a relationship. I'll explain. When we have to use is a, when we have to use has a, I'll explain. With examples, I'll explain now. Here, example 1. Here also, example 1. Example 1 is a relationship side. Example 1 has a relationship side. Example 1. Now, first example, later one more example also I'll explain. Now, see, class A, void show. System.out.println welcome. Class B, public static void main, string args. Now, extends A are written. Okay. Show method, is it instance method or class method? Instance method. How many ways to access? 2 ways. What are those? Object and object reference. Which class object required to call? A class object required to call. Okay. But what I'm doing is I'm creating B object. With that B object, I'm calling show method. Is it valid or not valid? Valid. Because there is a relationship. Otherwise, not valid. Suppose I'll remove extends A. Is it valid? Okay. Now you observe. Between A class and B class relationship is there. That's what valid. If I remove this relation, is it valid? Not valid. For calling show method, which class object required? A class. But extends A if you write, then B object also you can create, with that also you can call. it is valid. Extends A if I remove, it is not valid. See, relation is there, valid. Relation is not there, not valid. See, for example, one unknown person will come to your home. He wants to stay one day in your home. Will you allow? No. Suppose the person is either friend or relative. Will you allow? Relation is there, you are allowing. Relation is not there, you are not allowing. Here also, between A class, B class, relation is there, it will allow. Relation is not there, it will not allow. Okay? Now, here, this relation, say, extends A, if I write, it is allowed. Actually, which class object required? A class. Which class object I am using? Because B is a. Because B is a. That's what valid. This relation, inheritance, is called easy relationship. For calling show method, A class object required. But I am using B. Because B is a. Because B is a. Simple English. B is a. Now B and A both are same. That means that's what valid. Now B is a. If you remove this one, B is not a. Okay. If I write this one, B is a. Like that. This relationship is called easy relationship. Left side, example 1 you written, no? Example 1, left side. This one write it. This program write it. Is it over? Here you observe. P object created. P object created. That object referred by OB. Here, A class memory allocated, B class memory also allocated. In A class, show method is there. B class main method is there. Okay. Now, B object created, that object referred by OB. Here, in this diagram, is there any A object? A object is there? No. A members are present in B object, but A object is not there. In easy relationship, we can see only one object, that is B object, subclass object. The subclass object contains superclass members. Say, here hash code will be there. Write this diagram. Write this diagram. After program, left side only, right? Write the diagram. After writing this one, left side only, left side. After program, the diagram, left side. Next, after this diagram, note on, in the above example, B is A. In the above example, B is A. After diagram, that point write it. In the above example, B is A. First program, next diagram, next this line write it. In the above example, B is A. It is B is A. This relationship is called B is A. In this program, how many classes are there? 2 classes are there. How many objects are there? 1 object. Which object? Which object? B object. But here we are calling A member. It is A member because B is A. This is called is a relationship. But when we have to use is a, when we have to use as a, I'll explain. First, as a relationship, I'll explain. Now, if I remove, is it valid? Not valid. Now, between A class, B class, there is no relationship. Now, there is no relationship. Okay. Now, I'll ask some questions. Give me answer. Integer A equal to 10. It is which type of variable? Local variable. Now, A OB equal to, suppose A small a, suppose this is small x. Now, A small a equal to new A, if I write. Now, here, what is int? Data type. What is x? Variable. What is capital A? Class. What is small a? Object. Reference. Can I call capital A is a data type? Yes or no? Yes. Is it primitive data type or reference data type? Reference data type. Can I call it is variable? Is it primitive type variable or reference type variable? Reference type variable. Can I call it is a class? Can I call? No. Can I call it is object reference? No. This one data type, this one variable. This is class, you can also call data type. This is object reference, you can also call variable. Okay. Now this line I'll write here. Now it is which type of variable? Now this is, can I call variable? Is it a primitive type variable or reference type variable? Reference type variable. Is it instance variable or class variable or local variable? Local variable. Now this line also I'll write here. Now, is it instance variable or class variable or local variable? Instance variable. Now, what is instance variable? What happened? member of a class, member of a class. Okay, member of a class. X is a member of B class. It is called instance variable. Now, small a is a member of A class or B class? B class. Small a is a reference of which class? Small a is a reference of A class. Small a is a member of B class. Okay. Now, it is instance variable. It is also instance variable. How many ways to access instance variable? What are those? Which class object required? B class. B equal to new B. Okay. With this B, can I access X? Yes or no? Small b dot X. Valid or not valid? Small b dot small a. Valid or not valid? Valid. Small b dot small a dot show. Valid or not valid? Valid. Okay. Now here b dot a dot show. Valid no? Now actually this line not required, for understanding purpose I have taken. Now you observe here A class object I created as a member of B class. This relationship is called has a relationship. Composition, one in another. Now B has a. Now B has a. Previous program B is a. Now B has a. Now for calling show method, which class object required? A class. A class object created. That object referred by small a. Small a is a reference of which class? A class. Small a is a member of which class? B class. For calling small a, which class object required? B class object I created. That B referred by small b. That object referred by small b. With this B, can I call small a? With this a, can I call show? B dot a dot show. Now, between A class and B class, any relationship is there? Yes, that is has a relationship. Which class has a which class? B class has a class. B class has a class. Okay. Now B has a. Now right side, example 1 you written no? Right side this program right. It is a reference of A class and it is a member of B class. It is a reference of A class and it is a member of B class. It is a reference of A class and it is a member of B class. It is a reference of A class and it is a member of B class. Is it over? It is a reference of A class and it is a member of B class. For calling show method, A class object required. Now A class object, it is a member of B class. For calling that reference, B object required. B object I created. So B dot A dot show. Now show is a member of which class? A class. A class reference is a member of which class? B class. That's what B class, A class show. Like that we are calling. See, file, save. I'll compile. Okay. Now, the diagram you observe. B object created. In this B object, A reference is there, as well as main method is there. It is referred by small b. Here small a refers A object. Here show. Like this. Write this one. After writing this diagram, in the above example, B has a A. Object? Yeah, memory allocated in heap area. All objects are stored in heap area. JVM architecture, I'll explain, not completed. JVM architecture, 5 memory blocks I given. No? That is how to teach JVM architecture. No, actually, methods in method area stored, objects heap area stored, local variable stack area stored, native method native stack area stored, execution statement PC register stored. That is separate one class I'll take. Now concentrate on concept, internal memory later. JVM architecture, separate class I'll teach. Present heap area, stack area, leave it. First, how it is working, you concentrate. Later I'll explain. JVM architecture, separate class I'll take. One class I have to teach about JVM architecture. In the above example, B has a A. Is it over? Now, in previous diagram, this diagram you observe, previous diagram is a relationship diagram, has a relationship diagram. 2 diagrams you observe. In is a relationship, how many objects are there? 1 object. Which object? B object. Has a relationship, how many objects are there? 2 objects. A object also is there, B object also is there. Okay. Here 2 objects we can see. There 1 object only we can see. There can we see A object? No. But A members are present in B object. But A object can we see? There is no object. A object is not there. A members are present in B object. But here A object also we can see. B object also we can see. Between relation is there. Okay. Here B has a. That is B is a. Okay. Now when we have to use is a relationship, when we have to use as a relationship while developing projects, for understanding purpose, one general example I'll take. With that you'll get a clarity. See one general example, because based on real world examples only, this object oriented programming introduced. Okay. See, while teaching class and object, I compared with plan building. I compared, no? You take anything in the world, it is object. For that, one plan will be there. Okay. Suppose why mouse is like this only, there was one plan. Why keyboard is like this only, there was one plan. Why monitor rectangle shape only, why it is not circle, there was one plan. You take anything in the world, that is nothing but object. For that object, definitely one plan was there. Without plan, will they introduce? No. Anything in the world you take, whatever appears to you, for that one plan will be there. Okay, like that. Like that, based on real world examples only, these concepts also introduced. Okay. For example, one general example. I'll ask question, which relationship is there? You give answer. It is possible. Okay. Apple and fruit. Apple and fruit. First relation is there or not? Apple and fruit. Relation is there, no? No. Which relationship is there? Is a or has a? Is a. Apple is a fruit. Apple is a fruit. Now, can we see apple? Yes or no? Can we see fruit? No. Where is fruit? No fruit. But fruit properties inherited in apple. Fruit properties inherited in apple. Previous diagram, how many objects we can see? Which object? A object can we see? A like a fruit, B like a apple. A class like a fruit, B class like a apple. But fruit we cannot see, no? Apple we can see. Apple is a fruit. Fruit properties inherited in apple. Fruit properties inherited in apple. So, previous example, A class, B class. A class equivalent to fruit. B class equivalent to apple. Got it? Now, car and vehicle. Car and vehicle. Which relationship? Is a or has a? Is a. Car is a vehicle. Can we see vehicle? Can we see car? So, vehicle properties inherited in car. Vehicle properties inherited in car. But vehicle we cannot see. But car we can see. Okay? Bike is a vehicle. Car is a vehicle. Bus is a vehicle. That means vehicle properties are present in bus. Vehicle properties are present in car. Vehicle properties are present in bike. That's what you are calling. Bike is a vehicle, car is a vehicle, bus is a vehicle. But where is vehicle? We cannot see. We can see car. We can see bus. We can see bike. Okay. Is there any relationship between vehicle and laptop? Any relation? No relation. Okay. There is no relation. Vehicle properties are not present in laptop. So there is no relation. Okay. Now, car and wheel. Car and wheel. Relation is there? Yes. Which relation? Car has a wheel. Can we see wheel? Can we see car? Can we see A object? B object? Both we can see, no? Here. Car has a wheel. Car also we can see. Wheel also we can see. Okay. Now, vehicle properties one time inherited in a car. One time. Wheel. 4 wheels are there. More than one time required. Has a relationship. One time required is a relationship. Like that, we have to select. Suppose, see, here, I want to make a relationship here. Now, between A class and B class, any relation is there? No. Extends A. No relation is there. Can we write again extends A? No. One time only possible. It is one time only. So one time only possible. So it is a relationship. But has a relationship, you observe. A1 equal to new A. One more. A2 equal to new A. A3 equal to new A. N number of times you can write, no? A4 equal to new A. Possible, no? N number of times possible. This is has a relationship. Say it is nothing but class, something car, vehicle. Okay. Now class, car extends vehicle. Can we extend vehicle one more time? No. It is one time only. Suppose here class wheel. How many wheels? 4 wheels. You create 4 times. Wheel W1 new wheel. Like this, n number of times you can 4 times you can create, no? Like this. Like this possible. One time required is a relationship. More than one time required has a relationship. Like that, we have to select. For example, here, next, example 2. Note on. Example 2. Example 2, class student. Integer, roll number, string, name, string, address, integer, landline number, class student 2, integer, mobile number, string, mail ID. Ready, son? Student class, student 2 class. Present any relationship is there? Any relationship is there? No. Now, here, if you write like this, whose mobile number, whose mail ID? Definitely relation required. Okay. For that roll number name required, no? Roll number name, how many roll numbers, how many names required? One, no? Then which relation? Is a relation. Like this. Write this one. Student. In this case, one time only required. That's what extend student. Is it over? Now, extend student. If you write, what we'll do, we'll create object. Student 2, yes, equal to new student 2 will create. Here, memory allocated to roll number, name, address, landline number, mobile number, mail ID. This is one object created. Student 2 object. This object referred by yes. Okay. These are student members. Now here student 2 is a student. Okay. Write this one. In the above example, student 2 is a student. After program, diagram, after diagram, in the above example, student 2 is a student. Here, student members are present in student 2. But is there any student object? No. Now, rule number name, one time only required. For one student, one rule number only will be there. Two rule numbers will not be there, no? That's what one time required. One time required means is a relationship. Here, student 2 is a student. Student 2 is a student. Is it over? In this diagram, how many objects are there? One object. That is student 2 object. Student 2 object. In student 2 object, student members present. Fruit properties present in apple. Fruit properties present in apple. Student members present in student 2. That type. Okay. Now, one more I'll give. Here example 2 has a relationship side. Example 2. Suppose class name is address. Class name is address. Here. String house number. String street. String city. Integer pin code. It is on class. Okay. It is one more class, employee. Here, integer employee number, string name. Now, here, employee has two addresses, permanent address, present address. Then two house number, two streets, two cities required. Then which relationship? Has a relationship. If you write extends address, how many address comes? One. But as a relationship, n number of address you can create, no? Like that, you have to select. Now, what you can do, instead of that type, you create like this. Address, ADD1, new address, first address, address, ADD2, new address, second address. Like this, n number of addresses you can create. If you write like this. So, otherwise, even if you don't know, see the class names, which relationship better appears, you can give answer. Employee is a address better appears, or employee has a address better appears. Like that also you can select. Between employee and address, is a word better or has a word better with English knowledge. With English knowledge also you can select. Okay. Employee is a address or employee has a address. Like that also you can select. With English knowledge you can select. With Java knowledge means more than one means has a. Like that you have to select. Okay. Write this one. Employee has a address. Over. Now, ADD1, ADD2, it is a reference of address class and it is a member of employee class. It is a reference of address class and it is a member of employee class. It is a reference of address class and it is a member of employee class. It is a reference of address class and it is a member of employee class. Is it over? In address class, how many variables are there? Address class. How many? 4. What are those? House number, street, city, pin code. Employee class, how many variables are there? Employee class, how many? 4. Employee number, name, address 1, address 2. These two also variables. Reference variables. Okay. Now, see the diagram. Suppose you'll create object like this. Employee equal to new employee. You'll create. Then employee object created. In employee class, how many variables are there? 4. Employee number, name, address 1, address 2. House number, street, city, pin code. Again, 2 separate. House number, street, city, pin code. These all address objects. Noda? Employee object to address objects. Here total how many objects are there? 3 objects. 1 employee object, 2 address objects. Okay. Like this, n number of objects you can create in as a relationship. There is no limit. But inheritance only 1. 1 time inherited. Now, in this, after writing this diagram, first is it over? After writing this diagram, note down. In the above example, EMP, employee, has a address. So like this only write it in capital letters, hyphen, double quotes. Then you will understand. Otherwise it will become English statement, simple English. Okay, has a relationship. To understanding purpose, capital letters, hyphen, double quotes, write it. Employee has a address. Employee has a address. How many object-oriented principles are there? 4. What are those? Encapsulation, abstraction, inheritance, polymorphism. One principle completed. That is inheritance. Okay. Inheritance related concepts completed. But if you want to write multi-level inheritance, what we'll do? Class A, class B extends A, class C extends B. This is called multi-level. Okay. Hierarchical. Hierarchical, if you want to write class A, class B extends A, class C extends A. Remaining not possible. Remaining not possible, no? Multiple, not possible. Multipath, not possible. Hybrid, which includes multiple, not possible. So if you write like this, multi-level. If you write like this, hierarchical. But whatever concepts you studied, same. A inherited in B, here B inherited in C. Okay. Just if you want, you can write this code. Multi-level inheritance. Example. Hierarchical. A class inherited in B class. B class inherited in C class. Here, hierarchical. A class inherited in B class and C class. This is hierarchical. Here, A inherited in B, B inherited in C. Here, A inherited in B, A inherited in C. Monday, polymorphism. Monday, we'll see continuation.